Hi there. This video is going to cover part 2 of chapter 4, section 1, which we started last week. So as a reminder, if you are in class or at home and I am not there, then you are to take notes on these slides and then submit them at the end of the class period. So let's just do a quick review or quick recap of what we talked about on Friday. The first thing is if we're going to find our quadrant angles, and I do it in degrees, it's 0, 90 degrees, 180 degrees, 270 degrees, and then it doubled back around at 360. And if I wanted to add the radians, it would also be 0. This would be pi over 2. This would be pi, and this would be 3 pi over 2, all the way back around at 2 pi. So we want to start those. That's the foundation of what we're going to build, which is our unit circle, but we want to remember that those 4 spots for right now. Then we talked about how to find coterminal angles. Okay, if it's in degrees, we add and subtract 360. If it's in radians, we add and subtract 2 pi. And we talked about converting from degree to radians. And for these, we take our angle and we multiply it times pi over 180. And then from radians to degrees, and for these, we take that angle and multiply it times 180 over pi. We also talked about, what a radian was, how to graph it, the terminal side, the initial side, all that good stuff. But just this quick review of one of the major topics in that last set of notes. So we pick up with complement and supplement. Complementary, and this is just like it was in geometry, a complementary angle is an angle two angles whose sum is 90 degrees. So if I want to find the complement to an angle, I'm going to take 90 and subtract the angle from it when it's in degrees. If I want to find the complement and it's in radians, I'm going to do pi over 2 minus the angle. Supplementary angles sum to 180 degrees. Again, also something that we should remember from prior. To find the supplement of an angle, if it's in degrees, we do 180 minus the angle. If it's in radians, we do pi minus the angle. Now, both complements and supplements should be positive angles. So this means that if an angle has a degree measurement that's bigger than 90, it wouldn't have a complement. So if I ask to find the degree measurement of, or the complement to 100 degrees, it can't be negative 10, so there would be no complement. If I asked for the supplement of something larger than 180 or 2 pi, if I said find the supplement to 3 pi, I can't do 2 pi minus 3 pi and get a negative pi, so I would say there's no supplement. So if it's bigger than 90 or pi over 2, there's no complement, and if it's bigger than 180 or pi, then there's no supplement. All right, here's our example. Find, if possible, the complement and the supplement of each angle. So again, complement 90 or pi over 2 minus the angle, supplement 180 or pi minus the angle. So when I look at A, if you don't catch it right away, hopefully we see that that's bigger than a half, but if we don't catch it right away, I would do pi over 2 minus 3 pi over 4. This becomes 2 pi over 4 minus 3 pi over, that should be a 4, and I get negative pi over 4. Remember, it can't be negative. So A is no complement. And again, if you catch it from the beginning, this is obviously bigger than a half, then I can just go right there and say no complement. B is your supplement. So I would do pi or 4 pi over 4 minus 3 pi over 4, and I get pi over 4. And there's the supplement. B is in degrees. So it's less than 90, which means I'm going to find A, the complement, 90 minus 82, and that's 8 degrees. And B, 180 minus 82, which is 98 degrees. So supplement and complement, complement, and then supplement. Okay, then we get into arc length. So we talked about the arc length of the entire circle was the circumference. Now we're talking about just a segment of it. So if you could picture like the crust on a pie, we're trying to find the arc length of that. Now when we did this in geometry, we did the measure of the arc over 360 times 2 pi r. We've simplified it a bit by saying r times theta. So I usually reverse this order so that I can remember it as SOR, S-O-R. Remember, the order doesn't matter if it's multiplication, so we can do it either way. So this is S represents the arc length. Here's the arc length. Don't ask me why S is for length, but it is. Theta is the central angle, and this is most important. It has to be in radians. And then R is the radius. So this is my angle in radians. And then R is your radius. So example 5 says find the length of the arc. Remember, SOR, S equals theta times the radius. And again, theta in radians. So when I look at number 1, I get given the R is 3 and theta is 120. So the first thing I have to do is convert that to radians by multiplying by pi over 180. Zeros cancel here. 6 goes in here twice and 3 times. So theta is 2 pi over 3. So then S equals theta, which is 2 pi over 3, times the radius, which is 3. 3 over 1, these cancel, and I get S equals 2 pi. If it gave me a unit, I'd include it. If not, it's just units. So if that had said like 3 inches, then I would know to make that 2 pi inches. Number 2, again, same formula. This time, this is already in radians, so they did the hard work for us. 4 pi over 5 times the radius, which is 7, or 7 over 1. Nothing cancels across, so I multiply straight across, and I get 28 pi over 5. And this time I have a unit, which is centimeters. You always want to leave these exact and not put into mixed number form, so it's to stay as 28 pi over 5 or 28 over 5 times pi. All right, last up, find the radius of the circle with the given information. So I'm using the same formula, but this time I'm given different information and I'm looking for different information. This time I want to solve for r. So A says the length of the arc is pi and theta is 3 pi over 4. So let's plug in what we have. This is my S, pi equals theta, 3 pi over 4, times my r is what I don't know. So I can divide both sides by 3 pi over 4. And dividing pi by 3 pi over 4 is the same thing as multiplying by 4 over 3 pi. The pi's cancel here, and I get r is 4/3. Last one is B here. S is 24 pi. Theta is 4 pi. So again, S equals theta over r. 24 pi equals theta is 4 pi times r. Divide both sides by 4 pi. This cancels. The pi's cancel here. 4 goes into 24 6 times. And my radius is 6. All right, that's it for today. So make sure you submit your notes before the end of the class period so you can earn your full credit, and use the rest of the time to work on the 4.1 homework, which is due tomorrow morning. Have a great day, guys.